Welcome. Today we'll evaluate the definite integral of e to the negative absolute value of x from negative infinity to positive infinity. Let's first visualize what this function looks like. The function e to the negative absolute value of x creates a peak at x equals 0 and decreases exponentially as we move away from 0 in either direction. To evaluate this integral, we need to split it at x equals 0 because the absolute value function has different definitions for positive and negative x. So our integral becomes the sum of two integrals, from negative infinity to 0 and from 0 to positive infinity. Now let's consider what absolute value means in each region. For x less than 0, the absolute value of x is negative x. For x greater than 0, the absolute value of x is just x. So we can rewrite our integral as follows. The first integral becomes e to the x dx from negative infinity to 0, and the second becomes e to the negative x dx from 0 to infinity. Let's evaluate the first integral. The integral of e to the x is e to the x plus c. When we evaluate from negative infinity to 0, we get e to the 0 minus e to negative infinity, which equals 1 minus 0, or just 1. Now for the second integral. The integral of e to the negative x is negative e to the negative x plus c. Evaluating from 0 to infinity, we get negative e to negative infinity minus negative e to the 0, which equals 0 minus negative 1, or just 1. Therefore, our final answer is 1 plus 1, which equals 2. This result makes intuitive sense if we look back at our graph. The total area under the curve is equal to 2, with 1 unit of area coming from each side of the y-axis.